No, you won't. Until you try. You'll never be happy. You'll never be happy. Until you try.
All right. Good afternoon. This is MBF3C, College Prep, grade 11 math. You're listening to WASA Distance Education. I'm Pete, and I'm your teacher. So welcome to our second class of semester 2A. And I hope you're able to get your materials for the class and to log into Smart Bridget. I see Alex on there, so hi, Alex. And yeah, so we're going to just start Unit 1, Lesson 1 today, and I think what you'll find is it will go a little bit it'll go a little bit faster, just because we already covered some of the material. So that introduction that I did yesterday was just to kind of get you kind of ready to look at some of the topics that we're going to cover in this very first lesson. The problem is really where to start, right? So, okay, well, we already did all that. And here we go. So we're going to be on page 6 then of Unit 1. Okay, and I see we have Wiagama on. And is that Charlotte?
Yes.
All right. Hi, Charlotte. How's it going?
Good.
All right, good. So are you able to get onto the Smart Bridget as well? Okay, so I'll just be telling you what's going on, right?
Yep.
Okay, and then, but you were able to watch the video this morning, right?
Yes, I was.
Okay, and we'll get that sorted out. And just to let everyone else know that's listening, we found with Charlotte's help actually that there was a problem watching our videos on an iPad or some device, right? It was working okay on the browser, maybe, maybe not, but there was a problem watching it on devices. I think I've got that fixed, and I'm going to be, our videos should be visible from now on, even if you're on your iPad. So that's kind of cool. All right, so we're on page 6 then of Unit 1, so you can find it, and it actually talks about the opening of a parabola. Okay. So everything good? Okay, and I see we have Sajiko on there. Who do we have from Sajiko?
Anthony.
Okay, hi Anthony. How you doing?
I'm all right. I'm here by myself. My what's that thing called there that keeps the washer's not here?
Oh, DC. Okay.
But I figured it out on my own.
Okay, were you able to log into Smart Bridget then?
Not yet. I'm waiting on the worker here.
Oh, okay.
So
all right.
I'm behind the class.
Not really. We did a bunch of intro yesterday. I think you'll be all right. If you go to your Unit 1, page 6, and that's where we're starting.
Unit 1?
Yeah. So we're starting with Lesson 1, so you're not too bad. We did a lot of introduction yesterday. Okay.
How do I
so
my chat here?
Yeah. Okay. There should be a button called mute.
Yeah.
Okay.
So, okay, I'm going to go on mute now.
Okay, great.
Okay.
All right. So there we go. So it's fine. You know, we're going to be getting started and sort of sorting this out for the next couple of days. And that's why I'm going a little slower than some of the rest of the lesson. So if you find it a little slow, don't worry, it will pick up. We'll go a little faster once everyone gets on and we get everything sorted out. Now, and just because Anthony just came on there, if you missed anything, you can always go to my YouTube channel, and that's PW Wasa. Okay, and then look for this this class. If you do a search on 2A MBF3C, if you do a search on that, you'll find all the lessons for this class. We only have one from yesterday so far, but I'll be adding them as we go. And of course, there is also the WASA archive that you can watch it that way. And if you go through the instructions at the back of your study guide, it'll show you how to get it on the WASA archive. Okay, so, and I haven't checked that yet. I'm going to check that later this week and make sure everything's okay with that as well. Okay. So here we are right at the very beginning here, and we're going to talk about parabolas, and that's just this shape here. If we make a graph of it, that's what it looks like. Okay, it's a pretty common shape actually, and the reason that we're studying parabolas is that they show up in a lot of different places. Okay, and specifically, you know, science, of course, gravity. When you throw something, the shape very often follows a parabola. But it also shows up in business, in aviation, medicine, and in even automotive applications. So the parabola is a pretty common function, and it's a good way for us to just kind of get familiar with algebra, which is really what this whole first unit is all about. Just kind of getting our bearings on solving some equations, and looking at an equation such as this one right here, y equals a times x minus h squared plus k. That's an equation, and it may look like just a jumble of letters right now, but by the time this chapter's over, you're going to be able to look at that and tell us quite a bit about it, and that's what we're trying to figure out, right? Okay. So now, yesterday we were talking a little bit about the distributive property. I'll remind you as we go along, and also about multiplying signed numbers. Okay. Now, if you're if you get stuck, or if I'm saying something that you're not quite understanding, you're always welcome. If you're on SmartBridge, you can just click the hand raise right here. Okay, and then there you go. That'll let me know that you want to say something, and then you could type a chat message by clicking on this little guy right here. You can type me a chat message. If you just type a chat message and you don't raise your hand, I probably won't notice it because the message goes by very, very quickly. Okay. All right. So now this parabola, this format, this y equals a, and then in brackets x minus h squared plus k. That's the equation of a parabola, but it's called vertex form. Okay. And we'll show you a little later what exactly that means. But, well, okay, I'll tell you right now. It means that your h and your k, that's actually the x and y coordinates of the vertex, which is the highest or lowest point in the parabola. Okay, well, I tried to make, that was supposed to be right at the vertex, that little blue dot I made. So if you look on the parabola, that's the first one that's shown, which looks like an egg cup, doesn't it? Sort of an upside down, yeah, well, it's an upside down curve. So that's just pretty much what a parabola is going to look like, depending on the values of a, h, and k. Okay, they determine its shape, but also its position and orientation on the graph. Okay, so we're going to look at each one of those values. So remember then that when we write the equation of parabola in vertex form, then we're going to have numbers for a, we're going to have a number for h, and we're going to have a number for k. Right? And then we'll be able to kind of graph those. Or without graphing them, we can look at those numbers and we may actually be able to tell some things about it. Okay. Now, just to kind of tie this in, you may or may not have seen this in your previous math studies. You may have seen a quadratic equation or parabolas before in this form, ax squared plus bx plus c. You may have seen it in that form before. If you didn't, don't worry about it. But just if you have, I'm just trying to show you that this is another way of showing a parabola, and this is called standard form. Okay, and I think what you'll find if you've worked with standard form before, it can be a little awkward to figure some certain things out about it. Vertex form makes it really, really easy to find certain things out about the parabola, such as the vertex, because it's given right in the equation. Okay. Well, let's take a look at the first parameter here. Okay. The first parameter, the a, so that's the number that sits in front of the brackets. So y equals a, and then it times x minus h in brackets squared. So that whole thing in brackets squared plus k. Okay. So the a is going to be a number. It can be 5, it can be 1, but it can also be negative numbers as well. It could be negative 5, it could be negative 1. Okay, a really can't be 0, because if a was 0, then basically a times whatever's in brackets. If a is 0, then all we have is y equals k, and then all we'd have is basically a straight line. Okay, so we wouldn't actually have a parabola. So a can be any number, positive or negative, but it really can't be 0. Okay. So the simple thing about a is that if a is positive, then the parabola opens up. And if a is negative, then the parabola opens down. And maybe it's, I don't know, u, it's sort of shaped like u, right? So if a is positive, then it opens up. And if a is negative, then it opens down. Okay? And that's really all we say about a. Okay. So let's take a look at example 1 then, which is at the bottom of page 6. It says, using the value of a in the equation given, state whether its parabola would open up or down. Okay, so all we're looking at is a. We don't really have to look very hard at the rest of the equation. So we have to identify the value of a. Okay, so I'm just going to give you a second. Just think about what you would write down for the value of a. Okay, so remember that when we're looking at variables like this, we always look at this, or sorry, at constants or variables or anything. We're always looking at the sign in front of the number as well. Okay, so that a value is actually, it includes the negative sign in front of it. So in this case, a is negative 2. Okay, so it's just something to get used to, is looking at the sign as well. Now, if there wasn't a negative sign in front of the 2, then it would be positive 2. We don't put a plus sign in front of variables or constants when they're at the beginning of basically an equation or at the beginning of an expression. Okay, and it's just a style thing. Okay. So a is negative 2, and since a is negative, then what we can say about this parabola is that it opens down. Okay, and that's what we can say about it. Okay. Now let's. I'm just gonna maybe show you a resource here. Those of you that can't really see this, I guess I'll put the. I'll tell you what the links are, and I will put those on the. Whoops, where am I here? Okay. Sorry, I actually had. Really, I had something here. No. All right. Ah, there we go. Okay, so the first, where we're going here is www.desmos.com/calculator. Okay. So we'll go there. I'll put this on my website later.
Excuse me, can you repeat it again? The website?
Sure. Yeah, it's www.desmos.com. Okay. So there's a couple of these vertex for calculators. This one has a lot of features to it, so I'll put a couple of them on my Facebook page, so you can play around with this a little bit. So what this does is it lets you make a parabola. So y equals, and we'll just go x squared. There you go. So y equals x squared. So if our a was just 1, okay, because if I put a 1 in front of here, it's not going to change anything. Oops. And if our k was 0, because then it would be just plus 0, which doesn't change anything. Okay. So this is what a parabola just looks like without any, without h. H is 0 and k is 0 and a is 1. Okay. So if we change the value of a, so right now our a is 1. If I change it to 5, you'll see that it doesn't do anything, but it just makes the parabola a little narrower. Okay, which doesn't, it's not particularly interesting. But if I change a to a negative, notice that it flips the parabola over. Okay. So that, but it's still, the vertex of this parabola is still at 0, 0. Whoops, sorry. Okay. And that's because the h is right now 0 and the k is 0. It's kind of, if I put it in standard form, maybe it'll be a little clearer here. We don't normally write things like this, but you see the zeros don't really change anything, right? So if I change that to positive 2, then it'll flip back over. Okay, so basically the takeaway here is that if a is positive, then it opens up, and if a is negative, then the parabola opens down. Okay, and that can be a very powerful thing. Just a quick look at an equation. You don't have to graph it, right? You don't have to plug it into your graphing calculator. You don't have to sketch it. You can just look at the equation and have an idea of what it might look like. Okay. All right, so I'm going to go back to the lesson here. So now we're on page 7, right at the top of page 7. And they show us that indeed the value of a is negative 2. Okay, so as you're going through this lesson, take a look. Whenever you're substituting an a, an h, or a k, make sure that you're getting the sign as well. Okay, the sign that you need. Okay. All right. So here's example 2, and it gives a solution right there. But you'll notice that sometimes they do this kind of tricky part right here. And this is what I spent a bit of time talking about yesterday. Notice there's no a value given right there. And the reason for that is that if we're multiplying a parenthesis or something in parentheses by 1, well, we're not going to actually put the 1 in there. Okay, it's just noise. So whenever we see something like that, we assume that it's 1 times whatever's in parentheses. Okay, so in this case, then our a value is equal to 1. Okay, so since it's positive, then the parabola is going to open up. Okay, so there are a couple of tricks like that, and it's just a matter of having experience and noticing those. Okay, and it actually in the text here it says, remember nothing in front, in front, in front. I don't know. I think that should say in front. Sorry about that. Of the brackets implies a 1. Okay, and that's what they're trying to say. Okay. Now, one of the things we talked about yesterday was that if you had the same thing, but there was a negative sign in front of the brackets, x minus 3 squared plus 5, a negative sign in front of the brackets implies a negative 1 right there. Okay, so watch out for cases like that, because those are the tricky ones, and they'll throw them in the questions, in the key questions, in the support questions to kind of trick you. But once you're onto it, it'll be fine. You'll be able to notice it right away. Okay. All right. So let's take a look at the support questions. Now, when we do these support questions, you can do a few of them, and once you're happy with that you're getting the right answers, you don't have to do them all. I'd suggest you do maybe a couple of them, 3 of them or so, and then check the answers at the back. And then once you're happy with that, you don't have to do any more. You don't send in the support questions. They're there to reinforce and check your own understanding. Okay. Well, let's take a look at this right now. So this is on page, where are we? Page 7, I guess. Yeah, page 7 of Unit 1. And it says, for each of the following equations, state whether the parabola would open up or open down. So really, if you're going to answer this, we don't need a lot of computation there. Basically, what I would suggest you do to answer this would be state the value of A. So what's the value of A in part A here? Okay, I just made the worst looking A in my life here. All right, let's try this again. I'll change to red. So A equals. So we just have to look at what's in front of the bracket here. It's always going to be there. And we see that we have a positive 3. So A is positive 3. And then we say, well, it opens up. Okay. So that fully answers that question. Okay. Now, the reason I'm going through this is that there's a key question exactly like this. And so to give you an idea of what I would expect you to write there. Let's try B. This one looks kind of interesting. Now, notice that we have just a negative sign sitting in front of B. Okay, all we have is a negative sign there. And what that means is that they've just kind of, there's an implied 1 sitting in front of that parenthesis. Okay. So really what we have there is a negative 1. So A equals negative 1, and that's going to open, what's it going to be, up, down? All right, yeah. Okay, so that's going to open down. I don't know, D? Down, DN, whatever. Okay. All right, so that's how these go. So now that we sort of established that we kind of can do it for the simpler cases, let's look for some weird stuff. Okay, let's look for some crazy looking questions here. Okay, let's look at, for example, D. Okay, question D. It says y equals negative x squared. That doesn't look like standard form at all, right? So let's see how we can kind of make this work for us. Okay, so then D. Okay. Okay, so D is going to be y equals negative x squared. So if we were to write this in standard form, we have the negative sign. Of course, it's got to be negative 1. And then x squared really means that it's x minus 0 in brackets, right? And then plus 0, there's no k either. Okay, so this is really what it's trying to say to us. We would never actually write it that way. We'd just write it the way it's shown. But this gives us an idea of what A might be. So it's going to be, well, not so A equals negative 1. And then, of course, we know that negative value of A opens down. Okay. Let's see. Are there any other weird ones? I think we probably covered them all. Okay, so that gives you an idea then of how you would go about doing those. Now, if you just to kind of flip forward a little bit, let's go a couple of pages ahead. You take a look at this support question, and then take a look at key question number 1. Whoops, overshot the key question. Okay, so there you go. So key question number 1, which is on page 10. And notice it says for each of the following equations, state whether the parabola would open up or down. Okay, so there you are, and pretty well identical looking problems. As a matter of fact, one of them looks exactly like one we just did. Anyway, so that's how this is all going to work then. You'll have your support questions in the unit. You have a couple of examples, and you'll have your, okay, I lost my place. You'll have your support questions. You'll do a few of those, maybe all of them if you're having some problems, maybe fewer of them. It's up to you. And check the answers at the back of the unit. They should have the answers at the back. Now, a little note about those answers at the back. So usually they're correct. Every once in a while there's an answer that's not correct. So don't get too worried if you find your answer doesn't match. Try some other ones. And if there's one that you just can't get, just bring it up in class or email me, and we'll work it out. Okay. And that's true. It's not just our material. It's true of all textbooks. I have never seen a math textbook that didn't have mistakes in it. It's just the way things work. Okay, what happens is the books get edited, they get changed, and somebody will forget to change the answers. Okay. So that was A. So that wasn't, I mean, it was just a matter of looking then at the that initial value in the standard form. And the next thing we're going to look at is the role of H. Okay, right here. Now I'm going to tell you that the text is a little bit, can be a little bit confusing when they talk about H. And the reason is this. This is on page 8. Okay, so try to listen to my explanation here. It says here when an equation of the upper parabola is in vertex form in this form, the value of h shifts the function left if the value is positive. Now, this is the part that's a little problematic here. Okay? And the reason it's problematic is that the standard form of this equation includes this negative sign. Okay? So the way the text is talking about the value of h, as if we would set h to a value and we would rewrite this equation a equals x minus, and then some value of h in brackets. Okay? So this is what they're talking about when they're talking about h being positive or negative. Okay? And I've been telling you up till now that that when you have an equation with a variable in it, the sign in front of it is part of the variable. And that's true, but for whatever reason, the way the course text explains it, the value of h is treated as if the negative sign was separate, okay? Which is fine. Okay, we can actually come up with a rule here. Okay, and here's the rule. You can write this down somewhere. I'm going to put it right here because I don't want to move off the page. If you see the parenthesis here, it says x plus, and then there's some number there. Okay, what it means is that h is negative and the parabola shifts left. Okay, and if you say 8x minus some number, that means that h is positive and the parabola shifts right. Okay, that's the rule. Okay, now I'll explain why that rule is the case. Okay. And actually, they kind of explain it right here in this solution. All right, well, let's take a look at this example 3, and maybe it'll become clear here. We'll do a bunch more examples. It says, explain the transformation of the equation y equals ax plus 3 squared plus k, then graph it, and the function y equals x squared. So this is a kind of a common thing. They want you to be able to quickly graph it. Okay. Now, what they're saying is that h is negative 3, and it means that they're substituting the way I showed it just up above, and I'm just gonna have to kind of make a little room right here. What they're saying is that y equals a. We don't know what a is. We don't care what a is. X minus, and then minus 3. Gotta fix this. Oh. Squared plus k. Oh boy, I got a little sloppy. So what they're saying is that we're putting minus 3, substituting it for the value of h in that expression. Now, what we were talking about yesterday is this situation where we have a negative sign sitting in front of a bracket. Okay, and we talked about how it implies a 1, just as we were doing just before. That it means that it's a negative 1 in front of that bracket. And we talked about the rule that says that when you multiply two sign numbers together, if the signs are the same, then the answer is positive. So negative 1 times negative 3 is actually equal to plus 3. Okay. Which means if we go back to our equation and we write it out again working through that multiplication, we end up with x plus 3 squared plus k. And that's why if you see a plus sign in those brackets, it always means that the h value is negative. Okay. Because if the h value is positive, then it would just be substituted in there, and the negative sign would just be there, right? So for example, if I put positive 3 in there instead, we still have negative 1 times positive 3, but remember that when you multiply two sign numbers together, if the signs are different, then the answer is going to be negative. So negative 1 times positive 3 is negative 3. So we would then be writing x minus 3 instead. Okay. Now this is probably in all of lesson 1. This is, I think, probably the hardest concept. So don't worry if it takes you a little bit of practice to get it. You'll get it. Okay, you'll see enough of these that you'll be able to figure it out. But let's take a look at what this looks like on a graph. Okay, if we were to graph y equals x squared, this is the y equals x squared. It's just a it's just going to be a smooth curve right around the origin 0, 0, right down here. This is 0, 0. Okay, it opens up. Y equals x squared opens up because our a value is 1, positive. So what's happened here? Remember that our h value is going to be negative 3, and what's happened is that the x coordinate of our vertex has shifted negative 3 units to the left. And that's the bottom line, is that whatever h value is, that's how much it shifts the parabola left or right. Okay. So it seems really complicated, but really if once you work out what that h value is, and you consistently figuring out what the h value is correctly, then it's very easy to say which way the parabola is going to shift. If it shifts at all. If h is 0, then the parabola doesn't shift at all. Okay. All right, well, we can't just leave it there. We have to go and practice some of this. So let's take a look at what we got on the next page here. Okay. So let's take a look here. So it says y equals 3 times x minus 1 squared. It says for each of the following equations, state the value of h and describe the shifting of the function. So remember, we only want the h value. We don't want it. We don't need to know whether it opens up or down. We don't care. We just want to know the h value. Okay. So in this case, for 2a, we have 3 times and then x minus 1 squared in brackets plus 2. Okay. And so remember that if we see a negative sign in those brackets, it means that our h value is positive. Okay, so in this case, h equals, so it's going to be 1. And since our h value is positive and it's 1, then we know that it's going to shift 1 unit right. ht. Okay, now, right. I think right. Okay, r. I'm going to call it r. So remember how, well, yesterday, if you were here yesterday, you heard me say, don't try and cram things in if there's no room to cram in your answers. Yeah, this is exactly what I'm doing right here. Okay, could be pretty tricky to, you might get away with it there, but certainly you wouldn't be able to graph. Okay. So that's what they're telling us then. So the h value is positive and it's going to go 1 unit to the right. Now let's say that you're still not convinced, you're still not sure about this. What I suggest you do is go to that website and that I just showed you and just plug in the equation and you'll see what happens. Okay, so I'm just going to flip back to the website right now. Okay. There we are. And so I'm just going to type in this this 2a on page 9. So it's y equals 3 times x minus 1 squared. And the way you get that, there's a little square button right here. I just had to bring the keyboard up. And then plus 2. Now, it's also going to shift on the, it's going to shift a couple of ways here. But There we go. All right. So you notice that what we really care about is the horizontal shift, and you notice it's shifted over exactly 1 unit. Now on the graph, keep in mind that the big increments are 2, right? So it's 2, 4. So that means that the 1 is halfway between there. So notice that it's shifted over by 1. If I change that, instead of x minus 1, if I change it to x minus 2, it's going to go over to the 2. You see? Okay. Now, if I change that to be a negative, the h value to be a negative number, what I would have to do is put a negative sign in there. And there we go. And you notice that it went 2 units to the left now because h is negative. Okay. But if I were to multiply this out and sort of simplify it, the negative times a negative, that would actually give me a positive 2 in the middle there. But notice it's not going to make any change at all to the, whoops, it's not going to make any change at all to the actual graph because plus 2 is exactly what negative times negative 2 works out to be. Okay. So this is a great tool here. This is desmos.com, desmos.com/calculator. And you can go there and you can have a just play around with it, and if you're doing the key questions and you want to check them, or you're a little confused, you can go ahead and plug in those numbers. Okay. In a regular grade 11 class, everyone have a graphing calculator. A little tricky to give everyone a graphing calculator here, so this is the next best thing. Okay. All right, let's go back to our support questions. So now you get an idea of how we're going to answer these and the types of things we're going to look at. Okay, so as long as you see a negative sign in these questions, and we're back on page, where are we here? We're on page 9, support question 2. So as long as you see a negative sign inside the bracket, I'm having my problems here. Okay, then, okay, yeah, so, okay, so can you hear me, Alex? Is that a yes? Okay. Oh yeah, of course. Yeah, you can hear me. Okay. So yeah, what I'm saying is that the way they define h in the text and the way we're gonna work with h is that the x minus. Okay, I'm having my problems here. Okay, just a sec. Is that the okay? Just sorry, having a little. There we are. Not really sure what I've done here to my. I have a little technical difficulty. Sorry, guys. Okay, lock. Here we are. Okay. So if the h value, all right, let's try it again. So they define the h value as just the number, and it comes with its own sign. But if you see it like this one right here, b, still having my problems. Sure. Just there we go. So let's take a look at 2b. So it's negative, and then so negative and x minus 3 squared. So the only way to get a negative number for h there, or the only way to have a negative sign there is if h is positive. So in this case, x minus 3, that means our h has to be positive. Okay, so this is a tricky part where the h value is the number, and if the expression in the brackets has a negative sign in it, it means h is positive. If the expression has a plus sign, which I don't actually see any in here, it means that h is negative. So let's go back to our calculator then with b and take a look at that, because that should shift the graph 3 units to the right. Okay, so I will type that in here. So that's going to be y equals negative, and then it's x minus 3 squared. Okay, and there's no there's no k value. So notice that we went 3 units to the right. And that's because the h is positive, but the expression is x minus 3. Okay. If we made h negative, then this would evaluate to plus 3. I know, that seems backwards, doesn't it? And it would then shift it to the left. And the reason for that isn't that you have a plus sign here. The reason for that is that this means that the h is negative. Okay. Did I answer your question? Just, yeah, let me know if I didn't, or if I did. As a matter of fact, let's take a look at support question 3 here. Okay, all right, yeah, and you can check these. Take a look at support question 3. A. Now it says graph y equals x squared, and I'll actually show you that in a sec. But first, I just want to kind of give you sort of a chance to tell what the h values are. So take a look at A and ask yourself, is h positive or negative there? Or what is the h value right there? H equals. Okay. So do I have a brave volunteer who can tell me what the first one would be? What's the first h value going to be?
Negative.
All right. Thank you. Yes, it's going to be -4. Exactly. And the reason for that is that if we substitute y equals x minus -4 in those brackets, when we, and then it's squared and all that, when we work out this part in the middle, we end up with x plus 4. And that's the only way to end up with x plus 4 there. Okay, great. Okay, well, how about B then? So is h, what is the value of h for B? Sorry, you can shout out. It's a very small class.
Positive.
Exactly. H is 1. It's positive 1. Okay. And that's because it's standard, the standard form x minus h, and the h value, then the only way you can have a positive or a negative sign in front of that is if h is positive. Okay. And then over here we see we have a plus sign, so we know that h is -2. Okay. Yeah, it seems backwards, doesn't it? And that's why I'm spending so much time on this. Trust me, the next one is not like that. Okay, so the A was pretty easy going, right? The K is going to be pretty easy going, but that H is just it's a little tricky. But anyway, having been able to figure those out, then it means that you're able to quite easily graph these things. So let's take a look. I'm going to make a blank page. You can still look at your handout. I'm just going to make a blank page. And what we'll do is we'll try and, now when it says graph, if you wanted to, you could plot a few values for x and y, maybe a -3, -2, -1, 0, 1, 2, 3. And you could actually plot them out if you wanted to on graph paper. But when it says graph, really what I would like to see, what I'll give you the marks for, because I don't want you to waste a lot of time on this. So this is the first one. It's x plus 4 squared. And we've already decided that our h is -4, which means that it shifts left 4 units. Okay, so we already know that. We know that our A value is positive because it'll open up, and we know it's positive because there's nothing in front of that. We know it's a 1 then. So let's see what it's going to look like. Well, this is our y, this is our x. Let's draw the regular parabola. It says to draw y equals x squared. Okay, so y equals x squared. Okay, so that's what y equals x squared is going to look like. And now we'll change colors and we will draw a parabola shifted left 4 units, but it hasn't shifted up or down. So we'll just say, all right, this is -4 right here, so that's the vertex. Whoop, there you go. And this is going to be y equals, what is it? It's x plus 4 squared. Okay, so that's what that's what I'm looking for that kind of question. Okay, so don't spend a lot of time on it. When it says graph it, interpret that to mean sketch it. Okay, because otherwise you'll waste a lot of time drawing graphs because it takes a while to calculate all those tables of values. You don't have a graphing calculator. Most of you don't anyway. Now, let's say that you weren't really sure. Let's say you got that and you're going, I don't know, I don't know whether this is right or not. So then go to the website and plug in the equation. So the website, and then it's x plus 4 squared, right? So it's x plus 4 squared. There you go. So it shows you. Oh, I forgot the negative sign. I was a little scared there for a minute. And of course, you also want to know what the regular one looks like. There you go. Y equals x squared. So this little tool then shows you what the standard, just a regular parabola with a equal to 1 and h and k 0, and that's the green here. And then the red line shows you what your transform version is. So if you got h -4 and you said it shifted left 4 units, then you got the right answer. Okay, so I'm just going to flip back now to the well, okay. Let's see, back to the lesson. Okay, so you see here that the key then to solving this question 3 was just figuring out the h value, really. So that's the part that I want you to focus on for this. Okay. So for B, we're going to have our h value is 1 because this negative sign in front of it tells us it's a 1. I mean, it's a positive value. Okay. And then whenever you see a plus sign in the brackets, you know that your h is going to be negative. Okay. So it's just one of those things that I really wish there was maybe a stronger explanation, but there really isn't. It's just a strange way that we interpret the h. Okay. All right. So let's take a look at k then. K is the variable that's at the end of the vertex form, and that's how our shift up and down. Okay, and that's the y value of the vertex. Okay. So, and really all it is it shifts it up by if it's positive or down if it's negative. Okay, so that I think it's a little easier to sort of see. So here's example 4, and we're on page 9 here. So you see we have plus 5. Okay, and so it just shifted us up 5 units. Okay, so this is going to be a 5, and that's all it did. This is this outer parabola, which I'm going to outline in red. That's just y equals x squared. Ooh, y equals x squared. Okay, and then the inner one, which I'll outline in green, is just it's just y equals x squared plus 5. So our a is 1, and our h is considered to be 0. Okay, and our k, which is what we're interested in, is plus 5. So it just shifted the whole parabola up 5 units. Okay. So hopefully that's a little easier to see. Now you could find where it'll say x squared minus 5 or x squared minus something, and all that means is it shifted it down. And there we go. So this should be page, I don't even know what page we're on. Page 10? Yeah, looks like page 10. Okay. So, whoa. Oh yeah, so for 4, they're going to ask us, for each of the following equations, state the value. So state the value of k and describe the shifting of the function. So in this case, it's just with k. Yeah. You know what? It says describe the shifting of the function. I think we should describe all the shifts here just to be on the safe side. Okay. Because now we don't have any variables, so we can actually tell you each and every shift. Okay. So let's interpret question 4 to mean for A, H, and K. So the easiest way to do that, I think, is to write them out. And it's not telling us to graph it, so really it just wants us to tell the shift. So I'm going to flip to a blank page here. You can still take a look at the top of page 10. Okay, and I'll just rewrite this. Now, yesterday I said that I didn't want you to write out the questions again if you're using a separate sheet of paper. I mean, you're welcome to do it, but I really, I do it if you need to, but not for me. I just need the question number and your answer. Okay. So I'm writing it out just because I find it a little easier to follow this way. So it says, for each of the following equations, state the value of k and describe the shifting of the function. Well, in order to describe the shifting of the function, we kind of probably want to do the a, the h, and the k, right? I mean, that'll help us, right? So a, h, and k. So in this case, our a value just it's positive 3, so we just write 3. Now, is that going to open up or down? Okay. So we'll think back, and of course our a value is positive, so it's going to open up, right? Now our h, remember that if you see a negative sign there, it means our h is positive, and that means it's going to shift right, plus 1. I mean, I could write out the word right, but there's only 2 possibilities, right or left, so I think I can just put an r down, plus 1. And now k, which we just learned about, k is positive 2, and so it's going to shift up plus 2 units, right? I think I wasn't very clear on the a. Maybe I should say opens up. Okay. So I think that's pretty much how we're going to solve that one. Okay, I see that our time's up here, so you're welcome to contact me if you have any questions. PW Wasa is my Facebook page, or at my email that I gave in the course outline. And so take a look at those key questions, and you'll see that we pretty well covered all of them except maybe key question 7. That might be a little tricky, but take a look at it anyway, and we'll talk about it tomorrow. All right, well, thanks for joining us, and talk to you tomorrow.